Today we're going to be talking about linear equations and functions. So hopefully you've already looked at a few examples, but let's go ahead and do a few more. So this first one says solve or state there's no solution. So unlike the last section, now we have an equal sign where we're actually trying to solve these expressions. So the first couple of steps to this problem are the same as in the last section. Specifically, we want to make sure that the numerator and denominator of every fraction is factored. And it is in this case. All of these numerators and denominators are completely factored. And then the second step is we want to find the least common denominator. Okay, so we look at the first denominator that has an x minus 3. That's definitely going to have to go in. Everything from the first denominator has to go in. Then you go to your next denominator, it has an x plus 1. Do we already have an x plus 1? No, we don't, so we're going to have to include an x plus 1. And this is going to be our least common denominator. Now we don't really want to multiply this out. It's best to leave it in factored form. And now here's where the problem starts to differ. When you have an equal sign, you may remember when we were just trying to simplify, we multiplied by only what was missing from the denominator for every fraction. But now that we have an equal sign and we're trying to solve, we want to multiply both sides by the entire least common denominator. So specifically, we're going to take literally every single term in the original expression and multiply it by the entire least common denominator. And we're not doing it on the top and bottom either. So you may remember from last section we multiplied on the top and the bottom, but now we're just multiplying sort of on the top, because we had to do it in the last section on the top and the bottom to sort of keep things in balance, so that we just changed the way that the expression looked. But now we're keeping things in balance by multiplying on the left side of the equal sign and on the right side of the equal sign. Okay, so we're just multiplying every single term by the least common denominator. And the effect of this is we're going to cancel out all our denominators. Here the x minus 3's cancel. Here there's no denominator. Here the x plus 1's cancel. So we're going to have 4x minus 1 times x plus 1. Maybe I'll go ahead and distribute this 4 to the x minus 3 and get 4x minus 12 times x plus 1. Here, I've just brought down the x plus 1. And here we're going to get 5 times x minus 3. So now we still have to actually do all this multiplication and combine like terms, etc. But what we've done is eliminated all our fractions, which makes this problem so much easier to solve. So now we're just going to use skills that we've used hopefully before. We're going to multiply all these things out, and then we're just going to combine like terms and see what we get. So here we're going to get 4x squared, and then plus 4x, and then minus x, and then minus 1. Here we'll get 4x squared. We distribute the 4x to the 1. We're going to get plus 4x, then minus 12x, and then minus 12. And then we're going to distribute this 5 and get plus 5x minus 15. Okay, and we want to combine like terms. Okay, so on the left-hand side, we can combine the 4x and the negative x to get 3x. And then on the right-hand side, we've got a 4x minus 12x plus 5x. So positive 4 to go with negative 12, that's going to be negative 8. Negative 8 plus 5 is going to be negative 3x. And then we also have this negative 12 and this negative 15, which is going to give us a grand total of negative 27. So now we want to move terms and collect our x's on one side of the equal sign. So we can start by, let's just move these stuff on the right to the left-hand side. So minus 4x squared here, minus 4x squared here. Those are going to cancel, and these are also going to cancel. And then we're going to add 3x here to cancel this out, and add 3x here. So those cancel, but let's just go ahead and add up what we get for the rest of this stuff. So then we've got 6x minus 1, we're just bringing down that minus 1. And then on the right-hand side, we've got negative 27, because these two terms both cancel out. So 6x minus 1 equals negative 27. So then we're going to add 1 to both sides. So these cancel out. Negative 27 plus 1 is going to be negative 26. And then finally we're going to divide by 6. So x is negative 26 over 6, but of course that can be simplified because they're both divisible by 2. So this will be negative 13 over 3. Let me move that box up a little bit. Negative 13 over 3. Now, whenever you get to this step in the problem, you have to actually make sure this number makes sense. So if you go back, there are a couple of values of x that wouldn't make sense. For example, if we had gotten x is equal to 3, that wouldn't make any sense in the original, right? Because that would make this denominator a 0. Or similarly, if we had gotten x is equal to negative 1, that wouldn't make any sense either. So if we had gotten those solutions, we would just throw them out and say there was no solution. But we didn't. We got something that was perfectly fine, negative 13 over 3. Okay, so let's do one more. This problem in red. So again, we're going to solve or state there's no solution. And as always, when you have algebraic fractions, the first step is to factor everything, but everything is factored here. And then the next step is to make a least common denominator. So you go to the first denominator, you get an x minus 1. You go to the next denominator, a 3. Do we have a 3 already? Nope. So we have to have a 3 now. We go to the next denominator, which is a 6. Now, this is a little tricky. We don't already have a 6, but we do have a 3, so really we can just introduce a 2. Because 3 times 2 will be 6, right? So this 3 is taken care of, and 3 times 2 is 6, which means that the 6 is taken care of. Okay, so that's a little bit tricky. But hopefully it's clear what we're doing here. And then you go to the last one, and it's an x minus 1. Oh, we already have an x minus 1, so we don't have to add anything else. Okay, and then again, because we're actually solving, we're going to multiply literally every expression by the entire least common denominator. And I'm going to leave the least common denominator in factored form, like last time. So this term is going to get multiplied by everything, and then 1/3 will get multiplied by everything. And then 5/6 will get multiplied by everything. And then finally this 2 over x minus 1 will get multiplied by everything. Ooh, almost ran out of room there. Okay, and again, the reason we do this is to cancel out all these denominators. Okay, so here the x minus 1 cancels the x minus 1. The 3 cancels the 3. The 6 cancels the 3 and the 2. And then the x minus 1 cancels the x minus 1. So when we do this multiplication, we'll have 2x times 3 times 2, and then plus 1 times x minus 1 times 2, right, where this 1 comes from the numerator of this old 1/3. And then that's going to be equal to 5 times x minus 1. Everything else got canceled out. And then for the last term, we'll have 2 times 3 times 2. Okay, and again, now we've eliminated all our fractions, which means that hopefully we're much more comfortable solving an expression like this. So we still have to actually do all the multiplication and solve, but that shouldn't be too hard. Okay, so 2x times 3 will be 6x, times 2 will be 12x. Okay, then we can distribute this. 1 times 2 is 2, and we can distribute that 2 and get 2x minus 2 for this expression. We distribute the 5 here and get 5x minus 5. And then 2 times 3 is 6, times 2 is 12. Alright, so now we want to combine like terms on each side. So 12x plus 2x, that's going to be 14x. And then the minus 2 doesn't have any like terms on the left, and we want to combine any like terms on the right. So this negative 5 and this positive 12 can be combined. So negative 5, positive 12, that'll be positive 7. And now let's go ahead and subtract 5x from both sides because we need to collect all our x terms. So here these are going to cancel out. 14x minus 5x will be 9x. So now we've got 9x minus 2 equals 7. And then finally, we're going to add 2 to both sides. That'll cancel these out. So that'll give me just 9x equals 9. And the last step is we want to divide both of these by 9. So x will be 1. So here's our answer. But again, you have to make sure this actually makes sense in the original. So if you go back and look, are we allowed to have 1 as a solution? it turns out that we are not, right? If you try to plug 1 into this expression, you're going to get a 0 in this denominator. In fact, you'd get a 0 in this denominator as well, but really all that matters is if it messes up any one of your denominators, that's no good, right? Because if you try and plug in at 1, like if we let x equal 1, this becomes 1 minus 1, which is 0. That's no good, okay? So instead of this being our answer, we just scratch it out and say there's no solution. Because this was the only possible answer, but it turns out that that didn't make sense in the original problem. And you always have to check to make sure that your answer makes sense anytime you have variables in the denominator. So here when you see there's an x in this denominator and an x in this denominator, you have to go back and make sure that your answer that you get at the end actually makes sense with respect to those denominators.